So up to this point, we've been talking primarily about RxJava features that relate to synchronous programming in a single thread of control. But that's not really why you would ever want to use RxJava. You'd really want to use it to run things concurrently or in parallel. So we're going to start now with a discussion about key concurrency and scheduler operators and classes that are related to the observable class. And these operators arrange to run other operators in designated threads and or thread pools. And we'll be taking a look at the subscribe on, observe on, and scheduler's new thread factory method. We'll start with the subscribe on operator. This runs various other methods, subscribe, request, on subscribe, in a given specified scheduler worker. And you can see here that the scheduler worker is provided as a parameter to subscribe on. And that indicates what thread or what pool of threads to use to perform a given set of operations upon. And the reason why we parameterize this as opposed to baking it into the observable class itself is this allows the scheduler mechanism to be used or reused with the single class and other classes that are part of the RxJava family of reactive types. And so you'll see that the single class also has a subscribe on operator, and it's also parameterized by a scheduler. So that way we don't have to, we can reuse the scheduling mechanisms and have them independent of any given reactive type. Subscribe on returns the observable that's requesting the asynchronous processing. So you can see here that you get back an observable, and then that's where the computations will take place henceforth as those are chained together in a fluent programming style. The semantics of subscribe on are a little bit odd. In particular, if you place this operator in a chain, or rather, whenever you place the operator in a chain, it impacts the execution context of a bunch of signals that occur in that chain, in particular on next, on error, and on complete, which are how things flow through a chain. So here's an example where we put subscribe on after the range call, which we'll take a look at shortly. And what will happen is, starting from range, everything will run in the thread that's designated here in the parameter we passed to subscribe on. Interestingly enough, we could move subscribe on down in the chain, and that would still have the same behavior. So whether we put it up here or we put it down there, doesn't matter. The whole chain will run in the context of the thread, assuming that the operators have lazy evaluation semantics. The ones that don't would be things like the just operator, or the from array operator, or the from iterable operator. Those run in the assembly thread, not in the scheduler thread. Now, just a little twist, which we're going to talk in more detail about in a second. If an observe on operator appears later in the chain, that will change the thread context, where the rest of the operators in the chain below observe on will execute in the scheduling context given by observe on up until another call to observe on. This all seems a little bit mystical until you see examples that show how to use it. Project Reactor has an operator called subscribe on that works just like the one that's in RxJava. So let's now talk about the observe on operator. Oh, and I should probably mention that there's no real equivalent in streams. Streams has these parallel and sequential operators, and I guess in some sense calling parallel behaves a little bit like subscribe on in that it says run this in a parallel stream, but you can't designate the context in which to run it. It runs in the common fork join pool for Java streams. Let's talk now about the observe on operator. This also arranges to run the on next, on complete, and on error methods in a supplied scheduler worker, just like subscribe on did. And once again, the parameter here indicates what thread to perform the operation upon. And once again, it's parameterized, so we can reuse it. And once again, it returns the observable that's requesting asynchronous processing. But the observe on semantics are different and, quite frankly, more straightforward than the ones that you get with subscribe on. In particular, what happens is whenever you call observe on, then from that point onwards down the chain, the computations will run in the designated scheduler context, up to any new occurrence of observe on, if any. So you can actually have observe on occurring in multiple places within the chain. And that'll then change the context, but conceivably change the context if you give it a different scheduler to run on. And once again, it's a little bit mysterious until you see this all work out. And we'll take a look at some examples here shortly that illustrate how this works. Project Reactor has an operator in its Flux class called PublishOn that works the same as the ObserveOn operator in the RxJava Observable class. Why it's named differently from RxJava's ObserveOn operator is a mystery. Just shrug your shoulders, not really sure. It's rather puzzling, but they called it something different. Let's now talk about a scheduling operator that works with the Observable class. So this is the scheduler's new thread operator, which is a factory method that creates a new single-threaded scheduled executor service each time it's invoked. So every time it's invoked, it's going to create a new instance. And it returns the scheduler that will create a new thread for every unit of work. So it's a new thread is spawned for each of the different times that new thread is called. This thread is not reused, so it's really sort of limited. It's only going to be used in the context of that particular chain of calls. So here's a simple example. We are going to use this range long method, which we'll talk about later. It's going to generate values from 1 to S max iterations, whatever that might be. And we're going to subscribe the computations to run in a background thread, in a new thread that will publish those values. And then we'll do stuff with them later. So that's what subscribe on will do. It'll say, use this new thread that we created. When all the work is done in that particular chain, the thread is automatically terminated. So it won't stick around and be capable of being reused. Project Reactor has a method called new single in its schedulers, which will return a new thread. And it's similar but not identical because its return value must be disposed of. You have to explicitly dispose of it, otherwise you will leak memory, leak resources. So that's the end of our first overview of concurrency and scheduling operators in the Observable class. You will need to understand how to use some of these things in order to do programming assignment 4A, because you'll need to be able to run them in a background thread or background threads to perform the computations of crawling images concurrently.